This is R.D. Sharma solution, class 12 differentiation exercises 11.8. Now this type of question we have already done, and the way is to put the 2x is cos theta. It was minus 1 by 2 root 2 to 1 by 2 root 2, and I hope that you will be able to do this. Okay, the answer there was negative 1 by x. Here it is 1 by x. The procedure is exactly same. Okay, now coming to this question. See, all these questions will tell you why trigonometry and trigonometric equations and questions related to that are very important. Because here we are going to directly use that thing. Okay, those who want to do themselves, I have presented the answer. And those who want to understand, you will take this, we will take this, and du by dv we have to find out. And the boundary or the periphery is between negative 1 and 1. So u is this one. So this u is equal to tan inverse under root 1 plus x square minus 1 divided by x. Now here x will take it as tan theta, and when you put x as tan theta, you have to check the boundary also, because x is tan theta, x is between negative 1 and 1, so tan theta has to be between negative 1 and 1. This is what question is asking. So tan theta has to be between negative 1 and 1. Now you can just take the tan inverse of all the values. So this is going to be negative pi by 4, this is theta, and this is pi by 4. So what x we have to put, because when we put this x, you will see that it will come down to a very easy solution. 1 plus tan square minus 1 divided by tan theta. So this tan you have to put it here. I am writing as t for tan theta because this is an intermediary process. So 1 plus tan square theta is sec square theta. And under root of sec square theta is going to be sec theta. So final will be tan inverse sec theta minus 1 divided by tan theta. Sec theta is 1 by cos theta. So 1 by cos theta minus 1 and divided by sin theta by cos theta. So 1 minus cos theta by cos theta divided by sin theta by cos theta. Cos you can cancel. 1 minus cos theta by sin theta it will be. So it will be tan inverse 1 minus cos theta divided by sin theta. So 1 minus cos theta is what? See, in many questions we have already done this. So it is going to be 2 sin square theta by 2. 1 minus cos theta. And sin theta is 2 sin theta by 2 cos theta by 2. 2 cancel, 1 sin will cancel. You will get tan theta by 2. You will get tan theta by 2 and tan inverse tan theta by 2. And tan inverse need to be cancelled. And this is theta by 2. So that is what I was talking to you about this. So you have to take theta by 2 in order to check the boundary. So theta by 2 is going to be what? It's negative pi by 8, and here also it will be pi by 8. And that is going to be inside your periphery, which is actually when you cancel tan and tan inverse, it has to be between negative pi by 2 and pi by 2, which is actually this pi minus pi by 8, and pi by 8 is inside that. So no problem with that. Alright. So theta by 2, theta you already know from here. If x is tan theta, theta is going to be tan inverse x. So just write tan inverse x here divided by 2. And this is u. So du by dx you have to find out. So tan inverse is 1 by 1 plus x square. And this 2 is in the denominator. Alright. So du by dx. This I am going to use in a short while. Okay, let us come down to this sin inverse 2x by 1 plus x square. So v is equal to sin inverse 2x divided by 1 plus x square. Here also x you can put it as tan theta, and same kind of boundary or periphery checking you have to do. Alright, so you have x, this is equal to sin inverse 2 tan theta divided by 1 plus tan square theta. See, 2 tan theta divided by 1 plus tan square theta is sin 2 theta. So sin inverse sin 2 theta. You can cancel these. Sin and sin inverse 2 theta will come. So this, now when you check this. You have already checked for theta. You already checked for theta by 2. Now what you have to do, you have to check for 2 theta. So theta was between minus pi by 4 and pi by 4, if you remember. Same thing you have to do twice, okay? One for theta by 2, one for 2 theta, because these are two different entities. So this you already done. I've already showed you that. But now you have to check for 2 theta. So multiply 2 everywhere. It will be negative pi by 2 here, pi by 2. And this is 2 theta. So it is between the periphery, which is acceptable to us because we can cancel sine and sine inverse now. It has to be between minus pi by 2 and pi by 2. So what do you get? 2 into theta. Theta is tan inverse x. So dv by dx is equal to 2. Tan inverse x is 1 by 1 plus x square. Now remember, if you remember, du by dx we have already computed. And that has come already as this one only. 1 by 2, 1 plus x square. So now just du by dx we have to do. So we have to do du by dx divided by dv by dx. That is 1 by twice of 1 plus x square divided by twice 2 into 1 by divided by 1 plus x square. So this gets cancelled. 2 into 2 is 4 in the denominator. So what do you get? This gets cancelled. 2 into 2 is 4. Finally you get 1 by 4, that is du by dx. Okay. Differentiate this term with respect to this term. Again, lot of trigonometry, lot of trigonometric equations. I would suggest those who are not following this to go back, learn all the trigonometric formula again and again, because we are just simply using it here. So u is sine inverse 2x under root 1 minus x square in this case. So x is equal to sine theta here. So it will be sine inverse 2 sine theta, because x is sine theta. So under root 1 minus sine square theta, sine square 2 sine theta. Under root 1 minus sine square theta, 1 minus sine square theta is cos square theta. Under root cos square theta is cos theta. So you get 2 sine theta cos theta. 2 sine theta cos theta is sine 2 theta. This is sine 2 theta. So this 2 theta has to be in between what? 0 and 1 by root 2. But this is not 2 theta. This is first you have to do is x is between 0 and 1 by root 2. Then you have to put x as sine theta. Then you take the inverse. And then finally you have to check for twice of that theta. I hope you will be able to do it. Okay. So I'm not doing it. I will just keep it for you because we have done it already many times. So let us come to the next step. U equals 2 theta. 2 into theta is sine inverse x. So du by dx is 2 into sine inverse x is simply 1 by under root 1 minus x square. This differentiation we already know. So 2 into 1 by under root 1 minus x square it will be. This is du by dx simply. Next step will be dv by dx. Okay, dv by dx, let us see what do we get. So this we are going to just use while we finally divide the two terms. Range for both the things, the first part and the second part, that is sine inverse and sec inverse. For both you have to check the boundary and show that okay, this is within the limits. Second one is v equals sec inverse 1 by under root 1 minus x square. Same thing here. In place of x, you can just put it as sine theta. So what do you get? Check. This is up to you. Now, v equals sec inverse 1 minus x square. 1 minus sine square theta is what? Cos square theta. Under root cos square theta is cos theta. And 1 by cos theta is sec theta. So, you have sec inverse sec theta. But most of the time people just remember about sine, cos, tan. So the boundary checking has to be done on cos inverse. So the best way is to just invert it. It will be, this is exactly equal to cos inverse cos theta. Okay. Sec inverse sec theta is cos inverse cos theta. It's almost same. And this cos inverse boundary you already know from where to where it should belong. Okay. I hope you remember it. So you have to check for cos theta now here. Because whenever you cancel this cos and cos inverse, the boundary checking has to be done because you have put x as sine theta by yourself. X as sine theta nobody has asked you to do. So you have done it by yourself. So you have to show the examiner, okay, this is the boundary checking. So finally theta has come and it is within the boundary. I can tell you, if you just do it by yourself, you'll see that theta is sine inverse x from x equals sine theta. So dv by dx is going to be equal to 1 by under root 1 minus x square. So du by dx you know, dv by dx you know, and you can just divide these two. So du by dv, that will be your final result. So twice of under root 1 minus x square under root divided by 1 by under root 1 minus x square. This you can cancel, you get 2, and that is going to be your answer too. Okay, this is your final result. Okay, this question again, it's exactly similar to this one. There is no change, only the range is changed, 1 by root 2 to 1. The boundaries, see, the same question will give you different result if the boundary is different. Because if you don't think or don't worry about x belongs to 1 by root 2 comma 1, you will not be getting the right answer. Okay, this is very important. Same thing you have to do, and let me tell you, the boundary, the result will be inside your boundary or periphery, so don't worry about that. All right, so it will be inside that, and same result will come, because the previous question also gave us the same result. Here also you are going to get the same result, right? Cos x raise sin x raise cos x, and the result, because this in the previous 11.7 we have done this, 11.6 also to some extent we have done it, because those exercises where we used log to solve this differentiation. Here also u is equal to cos x to raise sin x, log u will be what? Sin x log cos x, and when you differentiate this, 1 by u du by dx is equal to, now you apply the product rule here. So sin x log cos x will be 1 by cos x is minus sin x, then plus log cos x here, differentiation of sin x differentiation will be cos x. Alright, so you have sin by cos as 10 and minus sin will be, just to make it simpler, we don't want anything in the denominator because that will complicate the thing. So better is to use this sin by cos as 10. So it will be tan x minus sin x. So minus sin x you can put in front, minus sin x tan x, and log cos x you can write first. So cos x log cos x. Otherwise it will be seen as log cos x. So 1 by u will go on the right. Write this. U is nothing but what? Cos x raised sin x. So du by dx is this one. We are going to employ this. We are going to use in the final result. Okay. So the next one is v equals sin x raised cos x. So log v will be equal to sin x and log sin x. This is 1 by v dv by dx, and cos x log sin x will be 1 by sin x will be cos x, plus log sin x cos x will be minus sin x. So write it as minus sin x. Now you can again use this. Okay, cos by sine, just take it as, because previously sin x by cos x we put it as, or took it as tan x, cos x by sin x as cot x. So cot x cos x minus sin x log sin x into log sin x. So log sin x, it will create confusion. So always take the sin x in front. So sin x log sin x, and we will go on the right. So here we will be sin x to the power cos x. Now du by dv we have to find out, so that you get du by dx divided by dv by dx. Okay. So let us divide these two. So we divide these two. So I'm just taking this and I'll just swap the position of the inner two terms so that we get a negative inside. So cos x raised sin x. Here you'll get cos x log cos x minus sin x tan x and divided by this one, sin x raised cos x, and then we have cot x cos x minus sin x log sin x. Alright, so this is your answer. This is the same thing. So this is more like the previous questions we have already done. There is nothing of this sort. So we have sin inverse 2x by 1 plus x square, and we have to do it with respect to cos inverse 1 minus x square divided by 1 plus x square. Periphery is between 0 and 1. Please remember, in both these terms, we will put x as tan theta. X is tan theta. So theta will be equal to tan inverse x. Tan inverse x. Okay. So final result, we will just check between 0 and 1, and I hope you'll be able to do that. We have done in a lot of the questions in previous also and this also. So u is equal to sin inverse twice of tan theta divided by 1 plus tan square theta. And this we have done a lot of time. 2 tan theta by 1 plus tan square theta is nothing but sin 2 theta. So sin inverse sin 2 theta. This sin and sin inverse we can cancel. We'll just check. I'll just check it for you just to recall. Okay, what exactly this is. So theta is tan inverse x. U is du by dx is 2. Tan inverse x is 1 by 1 plus x square. This is du by dx. Now coming to v. V is equal to what? V is cos inverse 1 minus x. In place of x I am writing tan. So 1 minus tan square theta by 1 plus tan square theta. 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. So cos inverse cos 2 theta, you can cancel cos and converse. And then we can just see that only 2 theta will come. And theta is nothing but tan inverse x from here. And dv by dx is equal to 2 tan inverse x 1 by 1 plus x square. Okay, so whether you check or not, you will see dv by dx and du by dx are exactly same. They both are 2 by 1 plus x square. Alright, so when you divide them, you will get 1. This is your answer. So 2 theta, this theta, see, basically x has to be between 0 and 1. And this x is what? Tan theta. Tan theta has to be between 0 and 1. And when we take the tan inverse, it's going to be, so tan inverse you take this, and this is going to be between 0 and pi by 4 multiplied by 2. So you get 0 and pi by 2 as the boundary or the periphery. So 2 theta has to be between this. Okay? That is true also. This question we'll take in the next discussion. Till then, thank you so much and take care of yourself.